Hello everyone, very good evening one and all. Welcome to the most comprehensive preparation app for all exams, BYJU'S Exam Prep, and warm welcome to the GATE AIMER'S 2023 series. Join the session quickly and mark your presence. I am Satya, waiting for you all to join the session. So guys, today we are going to discuss, revise very important concept of data structures, that is queues, along with practice. So guys, soon after you join, I'll be starting the session. So quickly join. Meanwhile, let me introduce myself. I am Satya with 15 plus years of teaching experience, mentored more than 35,000 students all over India. I am qualified in GATE, UGC NET, SET, and also certified by Cisco into networking and programming. Okay, guys, our GATE AIMER'S series, which is a free crash course in electrical, electronics, computer science, instrumentation, which we have started from 14th November, and it is successfully happening. All the subjects, important concepts we are discussing with practice. So guys, try to circulate this free crash course information as much as possible so that many students benefit out of this free course, right? And there is a mega workshop on 18th December for 2024 aspirants, where our expert Mr. Rakesh Talreja Sir will share the 7 key career prospects through GATE exam for engineering aspirants. So guys, don't miss this session. It is going to be very useful session on 18th December 12:30 p.m. Okay? And for electrical, electronics and instrumentation students, PYQs live discussion will be there, where the last 5 years PYQs will be discussed, solved live by our expert faculty, and this series we are starting from 18th December. Okay? And guys, mega mock test time. This is now the time for taking full length mock tests, all the 2023 aspirants. So where to go, where to take mega mock tests? Come on, our BEP is conducting mock tests on a regular basis, and current mock test would be active till 20th December guys, for you guys. So why late? Register for this mega mock test, and in this mock test you can analyze yourself. You will get all India level ranking, and you will be habituated for virtual calculator, and that GATE exam tool you can habituate, and you can assess yourself. Okay, now let us dip into the session with queues. What is a queue? We know that there are two types of linear data structures as linear, non-linear. Queue is one of the linear data structures. What are the other linear data structures? Arrays, linked list, stack, right? So queue is one of the linear data structures we have, and this queue follow FIFO order for insertion and deletion, generally first in first out order, right? And in the queue, insertion operation we call as NQ operation, and deletion operation is said to be DQ operation. And there are 4 types of queues we have: simple queue, circular queue, DQ or double-ended queue, priority queue, right? Simple queue, where insertion takes from one end, that is called rear end, deletion takes from the other end, that is front end. So From one end we insert, other end we delete. As you see in this diagram, from the rear end we insert, from the front end we delete. So what is inserted first, that gets deleted first. It is like a normal regular queue that you see at counters. So it strictly follow the FIFO order. And with the simple queue, there is a drawback. What if the once the queue becomes full, if the first nodes becomes free, the simple queue always says that the queue is full, the queue is full, the queue is full, though there are empty locations. That means the memory is getting wasted. That's why we have got this circular queue need. In circular queue, last element points to the first element, making the circular link. So what is the advantage of circular queue over simple queue? Better memory utilization. If the last position is full and the first position is empty, in circular queue we can insert element in the first position. That means the rear or front should rotate throughout the queue. So how we make it possible? Instead of normal increment, we do rear is equal to rear plus 1 mod size. That means modulo increment, both front and rear. Okay. And what is priority queue? It is a special type of queue. We can't say it strictly follow FIFO order. Why? Because here insertion occurs based on the first in criteria. Who arrive first, they are inserted first, or which element is arrived first, that is inserted first. But removal won't happen on the arrival basis. Removal happens based on the priority. So every element is associated with data as well as priority. If elements with the same priority occur, then they are served according to their order in the queue. So the first parameter for deletion is priority. When priority is the same, then arrival time we will take for deletion. Okay. And double-ended queue. In double-ended queue, insertion and removal can happen from either ends. From front end you can insert and delete. Even from rear end also insert and delete. So it won't follow the FIFO order. Because you insert and delete, then last inserted will be deleted first. Right? You are inserting, let's say, from the rear end, front end, and immediately you are deleting from the front end, then last inserted is deleted first. Similarly, you are inserting from rear end and deleting from the rear end, last inserted is deleted first. So this DQ you can use either as a stack or as a queue. From which end you insert, from the same end you delete, it works like stack. And if you insert from one end and delete from other end, it works like a queue. Here you can do both. That's why DQ can be used as both stack or queue, right? This DQ we can implement in two ways. Input restricted DQ, output restricted DQ. What is the difference? As you see in this diagram, input restricted DQ means input can be done only from the rear end but deletion can be done from both the ends. So input is restricted through rear end only. Similarly, output restricted DQ says output is possible only from the front end or rear end, only one end, but input is possible from both the ends. So output is restricted through only one end, that is output restricted DQ. Input is possible only from one end, that is input restricted DQ. Right? So these are what different types of queues we have. Now we'll move on to the question array immediately without wasting any of your time. Before that, guys, our BYJU'S Exam Prep is providing test series for you, because this is the time for more and more practice, because hardly we have 1.5 months with us for the GATE exam. So this is the time for stopping the learning and doing more focus on practice. So how many PYQs you practice, how many times you practice the same questions? You require more model questions. So where you get? Come on, our BEP is offering this test series where you can get unlimited access to full length mocks and subject wise tests. How you can access it, what is the procedure, you can find when you click on the link which is given in the description box. So in this test series, guys, all over you will be getting 4,000 plus questions. 4,000. So what else you require? 4,000 questions you are practicing means it's more than enough. In this 4,000, 640 plus full length mock tests are there. 30 plus subject wise and concept wise tests will be there. And it's not just you are attempting, you will get detailed analysis of your performance, and you will get all India level rank in that particular exam. And we are providing virtual calculator so that it gives the real GATE exam feel, right? And you can take this exam even from mobile also, guys. Not only from laptop, even from mobile also you can take it. And believe, every question is prepared at uttermost care. We made sure that every question is at the GATE level, because all questions are prepared by our experts who are all India rankers or fully experienced faculty and team. Okay? Now you can get our free ebook which helps for your GATE preparation, and scholarship test information where you can get our courses at less price, and you can get details about our workshop which helps you for focusing on your career and aim by subscribing to our BEP channel, and link is given in the description box. Okay, now let us start the practice on queues. Here is the first question we have. A queue is implemented using an array such that NQ and DQ can be performed efficiently. If so, which one of the following statements is correct? Where n is the size of the queue. Options: both operations can be done in constant time. At most one operation can be in constant time, other in linear time. The worst case complexity of both is linear, logarithmic. So what is correct? Which of these statements is correct? Remember, we are implementing using array. Whenever you implement using array, definitely you can perform both in constant time, because arrays support random access, right? Arrays support random access through index. So you can do this. Yes. Yes, Freaky. Yes, we can do both operations in big O of one time. Option A is correct. Exactly. Very good. Next question. Consider the following statements. Which of them are correct? Statements are: first in, first out types of computations are efficiently supported by stacks. Implementing lists on linked list is more efficient than array. Implementing queues on circular array is more efficient than linear array. Last in first out type computations are efficiently supported by queues. So, which of them are correct? Guys, let me understand who are watching this. Please mark your presence in the comment box. Give your responses in the comment box. In the chat box, I mean. We can say first in first out types of computations are supported by queues but not stack. So this is wrong. Similarly, last in first out are efficiently supported by stack but not queue. Right? So we have second and third options left. Implementing lists on linked list is more efficient than array. Of course, linked list support random access, sequential access only, but insertion and deletion are easy in linked list because it is of dynamic memory. Insertion and deletion are easy or more efficient, but with array implementation it is just a consideration or assumption that the elements are getting deleted, but really it won't happen, right? Just we will move the front end to the next location, from one location to another location, and logically we assume that the other element we can't access, henceforth it is deleted. But guys, that element still exists in the memory. But in the linked list, as soon as you insert, memory keep allocating. As soon as you remove, memory keep freeing up. Garbage collected. So yes, linked list implementation is more efficient than array implementation. And what about third statement? Circular array implementation of queue is more efficient than linear array. Yes, again in the perspective of memory utilization it is. Just now we have seen simple queue, circular queue difference. Yes. So yes, 2 and 3 are true. Got it? Next. Suppose a circular queue of capacity n minus 1 elements is implemented with an array of n elements. Assume that the insertion and deletion operations are carried out using rear and front as array index variables. Initially rear, front are 0. The conditions to detect queue full and queue empty are: how you can detect the queue is full or the queue is empty? It's a straight question. Suppose this is the circular queue. Okay. Suppose I am inserting, keep on inserting. Indices are 0, 1, 2, 3 and 4. N is equal to 5, let us say. So I am inserting 20, 30, 40, 50, 60. So rear is at 4, front is at 0. Now the queue is full. So when you can say the queue is full? When I increment the rear with modulo increment. So when the rear plus 1 mod n is equal to front, that means the queue is full. Right? Now let's say I am deleting. So I delete 20 and move to 1. I delete 30 and move to 2. I delete 40 and move to 3. I delete 50 and move to 4. I delete 60. So whenever front and rear are equal, that means all the queue is empty. So when rear is equal to front, that is the condition for empty, and when rear plus 1 mod n equal to front, that is the condition for full. So option A is correct. Got it? Next question. Suppose you are given an implementation of a queue of integers. The operations that can be performed on the queue are: is empty of queue, it returns true if the queue is empty, false otherwise. Okay. And delete of queue, it deletes the element at the front of the queue and returns its value. Okay. And insert function, insert the integer at the rear end. Okay. Makes some sense. Now consider the following function. Void f of q means we are passing the function, the q, as argument to this function. If the q is not empty, observe there is not symbol before is empty. So if the q is not empty, I is equal to delete of q. So delete happens from front end, and recursively you are calling this function. Then insert q of I after recursion, complete recursion is over. So it is something like head recursion. So we have more tasks, more lines to execute after recursive call. Okay. Then the question is, what operation is performed by this function? Options: it leaves the queue unchanged, it reverses the order of elements in the queue, it deletes the element at the front and inserts at the rear, keeping other elements in the same order, it empties the queue. So which is correct? Everyone? Let us assume I am taking some elements 10, 20, 30, 40 in the queue. Okay. So when I am inserting from 40 to 10 to 40, front will be at 10, rear will be at 3, right? So this is Q. Is the Q empty? No. So I is equal to delete of Q. So what gets deleted? 10 gets deleted. So that once it delete, front moves to 1 and call the same function. That means now F will get Q. Now the Q is having 20, 30, 40. Here is the front. Here is the rear. What happens here? Again another variable I is created. It delete the value from the front end and store in I and call the function again by moving the front. Now the Q has only two elements, 30 and 40. Here will be the front at 30, rear is still at 40. What happens with this? I is equal to 30, front moves to rear, right? So now call recursively again the same function. Here is the front, here is the rear. So what happens with this? I is equal to 40 and call the same function with empty Q. So whenever the Q is empty, the recursion ends. So now while written, insert Q of Q comma I. Whenever the Q becomes empty, guys, rear will be -1 or you say 0, no problem. So whenever you do insertion, rear, what you insert? 40, increment the rear, 30, increment the rear, 20, increment the rear and insert 10. So rear is at 3, front is at 0. So this is the outcome. That means what is happening? The given Q elements are reversed. So what operation is performed by this function? It reverses the order of elements in the Q. Got it? Next question. A Q is implemented using non-circular singly linked list. Okay. The Q has a head pointer and a tail pointer. All right. Let N denote number of nodes in the Q. Let NQ be implemented by inserting a new node at the head and DQ implemented by deletion from the tail. Okay. So Q is implemented using non-circular singly linked list. Like this you can take. The last is pointing to null. Head is pointing to the first node. Tail is pointing to the last node. So NQ insert here. DQ deletes here, last node. All right. Now, which of the following is the time complexity of most time efficient implementation of NQ and DQ respectively? NQ I want to insert at the front. It is very simple. New next is equal to head insertion at the front of SLL, and head is equal to new. So undoubtedly this can be done in constant time. Now I want to delete from the tail end. I can say simply free of tail, but what about this pointer? Means second last node pointer, that still points to that invalid location, deleted location. So you have to start temp from the head, and you should reach this node, and you should make temp next as null. Then only you can make free of tail. So you have to traverse from beginning to last but one node, n minus 1 traversals. So asymptotically you can say this is big O of n. So big O of 1, big O of n are the time complexities for NQ, DQ operations. Okay. Next, a circular linked list is used to represent a queue. A single variable P is used to access the queue. To which node should P point such that both the operations NQ and DQ can be performed in constant time? So here we have given the CLL. Options are rare, front, not possible with single pointer, node next to front, that means to the second node. To which node the P should point so that we can do NQ and DQ in the constant time? If you point to front, NQ can be done in the constant time, but DQ can be done in the constant time, but NQ linear time. It is not possible with single pointer. No, it is possible. Even if you point node next to the front, means at the second element, if you want to insert at the rear end, it takes constant linear time. Even DQ also takes linear time, because you are at the second node, you will insert always, you will delete always the front node. So you should traverse all the way back. So rear end, if you insert, if P points to, insertion is definitely easy. So NQ can be done in constant time, and deletion, yes, because it is just one step ahead the front end is. So DQ also can be done in constant time. So the P should point to the rear node for both to be performed in constant time. Okay. Next. Yep. That's it. So guys, these are different model questions we may expect from queues. In the same way, maybe you might be given some DLL, doubly linked list implementation, or circular doubly, or you may be getting the questions from binary heap, which is related to queues, priority queue, right? Or you may be asked to find what is the condition for finding empty or full in double ended queue. So here I have shown you the model questions. Okay. So based on that, you please keep up your practice. This is my Telegram group link. If you have not joined yet, please do join. That's all for today, guys. Thank you so much for joining the session. Please do like the session, share and subscribe to our BEP channel without fail. See you tomorrow sharp at 9 p.m. with binary heap concept. Okay? Thank you. Take care. Good night, everyone. Bye-bye.